Let us continue atomic structure. In the atomic structure, we will go for hydrogen spectrum. So in the hydrogen spectrum, we will take hydrogen gas. We will take hydrogen gas. We will take a hydrogen lamp. We will take hydrogen lamp. We are taking hydrogen lamp. In this hydrogen lamp, we are taking hydrogen gas. In this hydrogen lamp, we are taking hydrogen gas. Hydrogen gas we are taking. Then we are keeping two electrodes, one metal plate, another metal plate. It is connected to the battery. Here plus charge and here minus charge. Plus charge and minus charge. So this hydrogen gas, here in this vessel we have taken hydrogen gas and the metal plates we placed. It is connected to positive plate. It is connected to negative charge of the battery and we are giving discharge. This it is hydrogen lamp. This we will call it as hydrogen lamp. This hydrogen lamp is glowing. It is glowing in the sense it will emit light energy. So now we will see hydrogen lamp. We will see. Now we are going to see hydrogen lamp. So now we will see hydrogen lamp. So this is a hydrogen lamp. Hydrogen lamp, how it is there? See, hydrogen lamp. Here in this bulb, hydrogen gas is placed. Here hydrogen gas is placed. The bulb is glowing. It is emitting radiation. This is emitting radiation. Now see, hydrogen bulb is glowing. Hydrogen bulb on glowing, that emits radiation. That emits radiation. Okay. So in this bulb, what gas is there? Hydrogen gas is there. This hydrogen gas is there. You are passing current, therefore bulb is glowing. Bulb is glowing in the sense it is emitting radiation. Okay, which radiation it is emitting? This radiation. So it is hydrogen lamp. It is emitting radiation. We can say it is emitting radiation. So okay. Next. Okay. So this hydrogen, in this hydrogen lamp, we have taken a hydrogen gas. We are passing discharge. We are giving current. So it is emitting radiation. It emits radiation. Okay. So this hydrogen gas is emitting radiation. It is passed through a slit. It is passed through a slit. So we are placing a slit here. We are placing a slit here. Now this emitting radiation coming out. So hydrogen lamp is emitting radiation. That radiation is coming out. Now here what is placed means prism is placed. Here we are placing prism. This radiation is undergoing dispersion here. This radiation is undergoing dispersion here, and the coming out radiation, that is called emergent rays. Emergent rays is focused on photographic plate, and we are developing the photographic plate. We are getting what in the sense hydrogen spectrum. We are getting hydrogen spectrum. We are getting. Okay. Now we will see that hydrogen spectrum. We will see hydrogen spectrum. So this is a hydrogen emission spectrum. This is hydrogen spectrum. In this hydrogen spectrum, you see that here spectral line is present. Here spectral line is present. Okay. And here if you see spectral line is present. Here spectral line is present. Here you see spectral line is present. Here you see spectral line is present. Like this spectral line continues in which place means continuous in visible region, infrared region, ultraviolet region, like this it continues. Okay, so in the hydrogen spectrum, spectral lines present in which region? That is, one is ultraviolet region, second one is visible region, third one is infrared region. In these three regions, hydrogen spectral lines present. Okay, so this is what this is called a hydrogen spectrum. In this hydrogen spectrum, what is there? Spectral lines present. Spectral lines present. Sir, okay. Next, now, so we got a hydrogen spectrum. It gives what means hydrogen spectrum, we said. It gives hydrogen spectrum. Okay. So in the hydrogen spectrum, where spectral lines present? In the hydrogen spectrum. In the hydrogen spectrum, spectral lines present at where? In the hydrogen spectrum, spectral lines present at one is at Lyman at ultraviolet region. Spectral lines present in ultraviolet region. In ultraviolet region, spectral lines present. Then in visible region, spectral lines present. Then in infrared region, spectral lines present. In infrared region, spectral lines present. So in the hydrogen spectrum contains spectral lines. The spectral lines present at where means in ultraviolet region, spectral lines present. In visible region, spectral lines present, and in infrared region, spectral lines present. So in the hydrogen spectrum, spectral lines present in which region? One is ultraviolet, second one is visible, third one is infrared. Sir, in the beginning, in the hydrogen spectrum, spectral lines present in visible region, that is said by Balmer. That is said by which scientist? Means Balmer. Balmer studied spectral lines in the visible region of hydrogen spectrum. Therefore, the spectral lines present in visible region is called Balmer series. Balmer studied only spectral lines in visible region alone. Okay. So, Balmer studied spectral lines present in visible region of hydrogen spectrum. Those spectral lines are called Balmer series. Next scientist called Lyman. Lyman studied spectral lines present in ultraviolet region of hydrogen spectrum. That spectral lines are called what we can say means Lyman series. Like this, in infrared region, spectral lines present. Those spectral lines studied by Paschen, then bracket, then Fund. These three people studied infrared region spectral lines. That is, in infrared region means, shall we say it is having only one wavelength? Shall we say? No. It is having a range of wavelengths. So, lower wavelength, it is having a range of wavelength. In the infrared region, we will take a lower wavelength region, moderate wavelength region, higher wavelength region that we will take. Okay. In that first one is that is in that this fund series coming under which place? Fund series coming under which place means far higher region. Far higher region. That means higher wavelength side in higher region. This bracket series coming under a moderate wavelength, therefore higher region. Paschen series coming under a low wavelength higher region. Low wavelength in higher region, low wavelength side. In higher region, low wavelength side. Paschen series comes. So Paschen series comes in a low wavelength region of a low wavelength higher region. That's it. Paschen series. Sir, okay. So, in the hydrogen spectrum, spectral lines present in which region? One is ultraviolet region, second one is visible region, third one is infrared region. In the visible region, spectral lines present, that is studied by Balmer. Therefore, that series of spectral lines called a Balmer series. In ultraviolet region, spectral lines present, that spectral lines studied by Lyman. So those spectral lines are called a Lyman series. And in infrared, we are splitting this infrared into three types. One is near IR region. Next one is IR region. Next one is far IR region. Like this, in infrared region, we will classify into three types. Near IR means lower wavelength. Here spectral lines present, those spectral lines are studied by Paschen, therefore that is called a Paschen series. This is a far IR, that means a higher wavelength region of infrared, higher wavelength side of infrared. Here spectral lines present, those spectral lines studied by a fund, therefore that is called those spectral lines coming under fund series. This wavelength comes under in between near and far. This is lower wavelength side. It is higher wavelength side. It is in between these two. Here spectral lines studied by bracket, therefore it is called a bracket series. We can say it is bracket series. So bracket series means spectral lines in present in a IR region. This is a lower wavelength side. It is a higher wavelength side. It is moderate wavelength. This wavelength is greater than this and smaller than this. Like this is there. Sorry, okay. So now we will see. First, we have taken hydrogen gas here. This hydrogen gas consists of hydrogen atoms or hydrogen molecules or hydrogen homodiatomic molecules or heterodiatomic molecules or compounds or elements. This hydrogen gas consists of what? That you see. So first we are taking hydrogen gas in the hydrogen lamp. We are taking hydrogen gas in the hydrogen lamp. This hydrogen gas consists of hydrogen atoms, shall we say, hydrogen molecules, shall we say, molecules in the sense which type of molecules, okay, or shall we say element. Hydrogen gas consists of elements, shall we say, or shall we say hydrogen gas consists of compounds, or shall we say hydrogen gas consists of homogeneous molecules, or shall we say hydrogen gas consists of heterogeneous molecules. What shall we say? Hydrogen gas consists of which, shall we say? Heterogeneous molecules. Okay, which one shall we say? Now you say that now we have taken hydrogen spectrum. For taking hydrogen spectrum, we have to take a hydrogen lamp. In the hydrogen lamp, we are taking hydrogen gas. Now hydrogen gas consists of atoms or not? That you say. Hydrogen gas consists of atoms or not? We are asking that hydrogen gas consists of what among these? Hydrogen gas comes under which category of these? That means where under normal condition we have to consider. Sir, you are saying that hydrogen gas consists of some students saying that atoms, some students are saying that molecules. Hydrogen gas is not consisting, sorry, hydrogen gas consists of what? Some students are saying atoms, some students are saying molecules. Which one is correct? Sir, now we will say, we will take periodic table. We will take periodic table. In the periodic table, roughly 118 elements are there. 118 elements are there. In these elements, okay, these elements are classified into two types. One is called metals, another one is called non-metals. Okay, one is called metals, another one is called non-metals. Metals means mostly in solid state. Mostly in solid state, except what means mercury liquid, gallium is summer liquid. Gallium is summer liquid. That means what is the meaning of summer liquid? Means summer time it is in liquid state, in winter time it is in solid state. Therefore, it is summer liquid. Sir, so Metals in the periodic table 118 elements are there. They are classified into metals and non-metals. Metals are coming under mostly solid, except a few. One is mercury is liquid, gallium is summer liquid. Then cesium also coming under exception liquid. This is also, it is photovoltaic cell, so that it is also solid. Some temperature, if you change, it is liquid. So rest of the things are what we can say means sorry. Okay, you were saying about one student asking that in the hydrogen spectrum you said series, you said why didn't you say Ampere series? Ampere series also present. Ampere series also present, but in syllabus that is not given, so we did not consider. So in the hydrogen spectrum, spectral lines present, spectral series are present. One is Lyman series, next one is Balmer series, next Paschen series, next bracket series, next Fund series, and another one is called Ampere series. Ampere series is not present in a syllabus, so we are not taking that. Ampere series we are not taking that. Sir, we are not considering Ampere series because not there in syllabus. Sorry. Now, out of these elements, the one is called metals. Metals coming under solid. Solids in the sense, metals in the sense, mostly we have to say monoatomic molecules. Metals means generally we have to say monoatomic molecules. Generally we will say monoatomic molecules. Okay. Generally we will say monoatomic molecules. Okay. Metals means generally we will say monoatomic molecules. Second. Non-metals. Non-metals means what are the types possible? What are the physical states possible? Solid possible, liquid possible, gas possible. So which are gas? Which are coming under gas? In the non-metals, three physical states possible, which are coming under gas. Number one is noble gases. Noble gases. Noble gases means helium, neon, argon, krypton, xenon, radon. These noble gases always exist as, these noble gases generally exist as monoatomic molecules. Monoatomic molecules. Monoatomic molecules means for it will exist as atoms. That's all. It will exist as atoms. So for example, here we can say helium atom. Helium atom formula, if you say H. Helium molecule formula, if you say H. Helium molecule formula is H. Helium atom formula also H. Like this only we will say. So noble gases if you take in the noble gases, all are coming under monoatomic molecules. Noble gases coming under monoatomic molecules. Then what is the next gas? Next one is what means nitrogen gas. Nitrogen gas will exist as diatomic molecule. Sir, nitrogen gas existing as a diatomic molecule means what? Nitrogen atom, if you take nitrogen atom formula N. Nitrogen molecule, if you take nitrogen molecule formula N2. Okay, so nitrogen in the sense, nitrogen atom formula is N, nitrogen molecule formula is N2. So nitrogen exists as a diatomic gas. Okay. Next, oxygen. Oxygen exists as a diatomic gas. Fluorine exists as a diatomic gas. Bromine exists as a diatomic liquid. So bromine exists as a diatomic liquid. And iodine exists as a diatomic solid. Iodine exists as a diatomic solid. Sir, this is about halogens. Sir, okay. Then in the ozone, it's another one is there, that is in the oxygen, another one is there, that is ozone. Ozone comes under triatomic molecule. Ozone comes under triatomic molecule. Sir, in the nitrogen family, phosphorus is there. Phosphorus comes under a tetraatomic molecule. That tetraatomic molecule comes here. Phosphorus comes under tetraatomic molecule. Sir, that is in solid. Then in the oxygen family, one is there sulfur. That sulfur comes under octaatomic molecule. Sulfur comes under octaatomic molecule. Okay. So what about rest? Rest is monoatomic. Rest is monoatomic. Okay. Rest is monoatomic. Monoatomic molecules. Rest is what we have to say, means monoatomic molecules we have to say. In the sulfur, mostly S8, other things also possible, S2, S6 also possible. That later we will discuss. Superficial if you see like this present. So consider that in the molecules if you see which are diatomic, triatomic, tetraatomic, you consider that say diatomic means N2, O2, F2, Br2, I2. And another one is there. What is that means? H2. Another one is H2, hydrogen. Hydrogen is a diatomic gas. It is hydrogen is a diatomic gas. Okay. So in the periodic table, what is the physical state of elements? And what is the physical state of elements? Physical state, if you see, first gas. In the gas, only these are gas. Only these are gas. Okay. Only these are gas. In the liquid, it is a liquid and this is the liquid. Remaining all are solids. Remaining all are solids. So physical state is over. Next, atomicity. Next, what means atomicity? What is meant by atomicity? This atomicity means this says number of atoms per molecule. Number of atoms per molecule. Okay, number of atoms per molecule. Number of atoms per molecule is called atomicity. Now, we will take this. For this atomicity is 2 because this molecule contains 2 atoms. For this atomicity is 3 because this molecule contains 3 atoms. This atomicity is 8 because this molecule contains 8 atoms. This atomicity is 4 because this molecule contains 4 atoms. This atomicity is 1 because this is monoatomic. Okay, so atomicity means number of atoms per molecule. So consider that this is which are diatomic: N2, O2, F2, Br2, I2, H2 diatomic. Triatomic is ozone. Tetraatomic is phosphorus P4. Octatomic is S8. Remaining all are monatomic. That's all. Okay. Exception comes means maybe 1 or 2. In the syllabus it is there. In the syllabus point of view it is. Sir, okay. So we discussed how the periodic table elements are there. We discussed. Next we will see atom, molecule, element, compound, that we will see. Now, generally, all the matter in the universe is made up of atoms, which is smallest and we cannot see. Molecule means atoms combining together to give molecules. Atoms combining to give molecules. If you take diatomic molecule, it will have 2 atoms. Triatomic molecule, if you take, one molecule contains 3 atoms. Tetraatomic molecule, if you take, one molecule contains 4 atoms. Octaatomic molecule, if you take, one molecule contains 8 atoms. Like this molecule. Then element. What is element? Element means same type of atoms present means same type of atoms present means then we have to call that is as element. If the given substance contains same type of atoms, then that substance is called element. Compound means if the given type of substance, if the given substance contains different types of atoms, different types of atoms, then we will call that is as a molecule. If the given substance contains different types of atoms, then that is called compound. If the given substance contains same type of atoms, then that is called element. Now we will take. We have taken P4. This is a substance. This substance formula is P4. This substance contains only phosphorus atoms. So this contains same type of atoms. Therefore, this P4 is an element. P4 is an element. This P4 we can also say as molecule. Okay. So element we can say as molecule. Compound also we can say as molecule. Element we can say as molecule. Compound also we can say as molecule. So this P4 is element or compound. How to say? This P4 is an element or a compound. How to say? This contains same type of atoms, therefore it is element. It contains same type of atoms, therefore it is not compound. And it is also molecule. In the molecule, two types are there. One is called homogeneous molecule. Another one is called heterogeneous molecule. Heterogeneous molecule. Okay. Another one is called heterogeneous molecule. Homogeneous molecule means same type of atoms present. Homogeneous molecule meaning is homogeneous molecule means same type of atoms present. Same type of atoms present. Heterogeneous molecule means different types of atoms present. Different types of atoms present. Different types of atoms present. Heterogeneous. Heterogeneous means different types of atoms present. Homogeneous means same type of atoms present. Okay. So this P4 contains same type of atoms. Therefore, it is homogeneous molecule. In these four atoms present, therefore it is tetraatomic molecule. Like this you can see. Now we will take an example. Water we will take. We will take water. In this water, two different types of atoms present. One is hydrogen atoms present, another one is oxygen atoms present. So in water, two different types of atoms present. Therefore, water is a compound but not element. Water is a compound but not element. This is a compound. We can also call this is a molecule. This molecule contains different types of atoms. Therefore, this molecule is called a heterogeneous molecule. Heterogeneous molecule we can call. Okay. So like this, we can say atoms, molecules, elements, compounds like this. Sorry. Okay. Now we will come back to this hydrogen gas. Now you say, shall we say hydrogen gas means a normal condition you have to take. Hydrogen gas we are saying means condition is normal. At normal condition, hydrogen gas consists of atoms, shall we say, or we should not say. Hydrogen gas is made up of atoms, or hydrogen gas is made up of molecules. What shall we say? Or generally, if you see, all the matter is consisting of atoms, no doubt. But hydrogen gas existing in the form of what? In the form of molecular form, it is existing, or in the form of atomic form, it is existing. That is the question. Hydrogen gas is made up of molecules, hydrogen molecules or hydrogen atoms. What shall we say? Hydrogen gas normally. Okay. Hydrogen gas is made up of molecules, shall we say? Okay. You are saying that hydrogen gas is made up of molecules. That is homogeneous molecules, you are saying. Therefore, we need not consider this. So hydrogen gas is made up of molecules, that is homogeneous molecules. Which type? What is the atomicity of hydrogen gas? Hydrogen gas is made up of molecules, we are saying, isn't it? Homogeneous molecules, we are saying. What is the formula of homogeneous molecules of hydrogen? What is the formula in the sense we will say H2. Therefore, H2 means it contains same type of atoms. Therefore, we need not say heterogeneous. This hydrogen contains hydrogen comes under homogeneous molecules. So this formula is H2. So it is coming under which type means it comes under diatomic because the molecule contains two atoms. Molecule contains two atoms. Molecule contains two atoms. Therefore, it is coming under diatomic. So now in this hydrogen molecule, same type of atoms present. Therefore, we can call this is as element but not compound. Okay, this contains same type of atoms. So we can call this is as element but not compound. Sir. So hydrogen gas consists of what we came to know it. Sir. Hydrogen gas consists of hydrogen molecules. Sir. In the hydrogen gas, what is there means hydrogen molecules present. In the hydrogen gas, what is present means hydrogen molecules present. So now we will pass current into this. We are passing current. We are passing current into this. We are passing current means we are supplying energy to this. We are supplying energy to this. Okay, we are supplying energy to this. That means this energy means it is having quantum. This quantum is falling on this. This quantum is falling on this means this molecule absorb this quantum. This molecule absorb this quantum. This molecule absorbing quantum means this molecule energy becomes what? This energy of a molecule becomes high. Energy of molecule become high. Okay, so you are passing current. That means you are giving energy. That means you are giving quantum to this. So this hydrogen molecule taking this quantum. That means this hydrogen molecule is absorbing this quantum. So energy of this hydrogen molecule becomes high. Energy of this hydrogen molecule. Energy of this hydrogen molecule becomes high. We can say. Okay. So energy of hydrogen molecule. Energy of hydrogen molecule becomes high. Now you say due to supply of this one, this hydrogen molecules in the hydrogen molecules is there any change? Is there any change in the hydrogen molecules due to supply of this quantum? Due to supply of this quantum, energy of hydrogen molecules getting changed. Now what about its state? Will it remain in molecular form or will it convert into some other? Will it remain in molecular form or will it convert into some other? What shall we say? It will convert into what? It will remain in molecular form or it will convert into what? Sir. So you are saying that it is undergoing dissociation. It is undergoing dissociation. It dissociates to give atoms. Sir. So we are supplying this quantum. So hydrogen molecules absorbing energy. So it is becoming hydrogen atoms. Hydrogen molecules becoming hydrogen atoms. Sir. So due to supply of this current, due to passage of current, hydrogen molecules are converting into hydrogen atoms. Then passing of current is continued. Passing of current is we are continuously passing the current. We are continuously passing the current. That means we are continuously supplying the energy. We are continuously supplying the quanta. We are continuously supplying the quanta. This quanta is striking this hydrogen atom. So this hydrogen atom is absorbing quantum. Is absorbing quantum. So this in the hydrogen atom, this hydrogen atom is absorbing energy. This hydrogen atom is absorbing energy. So that energy of hydrogen atom becomes high. Energy of hydrogen atom becomes high. Energy of hydrogen atom becomes high. So, energy of hydrogen atoms become high means now in the hydrogen atom which is absorbing this quantum. In the hydrogen atom which is absorbing the quantum. Hydrogen atom means here nucleus is present. Around the nucleus electron cloud is there. Electrons present. Which is absorbing this quantum. In the hydrogen atom, electron is absorbing the quantum. So electron absorbs quantum. So electrons absorbs quantum means energy of electrons become high. Energy of electron becomes high, we can say. Energy of electrons become high. Energy of electron becomes high in the sense, shall we say it is going for excitation, shall we say, or it is going for de-excitation, shall we say, or it is remain in same state, shall we say. What shall we say? This electron is absorbing quantum. Therefore, its energy becomes high. Energy becomes high means, what does it mean? Energy becomes high means excitation. Oh, energy becomes high means electron undergoes excitation. Electron undergoes excitation. Electron undergoes excitation. That means energy of electron becomes high. Who made energy of electrons to become high? Who made electron to undergo excitation? Who made this? That means we made this one. How do we say that we made? Because we supplied current. We are supplying current. We are supplying energy. We are supplying quanta. We are making this quanta to fall on hydrogen atom. So we are making electron. We are making this electron to absorb quantum. So we made this electron to get higher energy. We made this electron to become excitation. So what will happen to the stability of this electron? What will happen to the stability of this electron? Stability of this electron will become high or will become low. What shall we say? Stability of this electron. Stability of electron becomes high, shall we say, or becomes low, shall we say. What shall we say regarding this stability? What do you say? So we supplied energy. So stability of electron, we made stability of electron to become low. So we made stability of electron to become low. Up to this we did. Okay. That means we made hydrogen molecules into hydrogen atoms. In the hydrogen atoms, electron energy we made it as high, and we brought electron to excitation, and we made stability of electron low. This our part. Now what electron will do? For this